everyone. I am Dr. Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, School of Business, Aditya University. In this present lecture, I am going to discuss how to find out initial basic feasible solution for a transportation problem using VAM technique, which is called Vogel's approximation method. So, this is the problem which I am going to consider to discuss how to find out initial basic feasible solution using VAM method. So, whatever the problem we are going to consider, first we have to check whether total demand is equal to total supply or not. So, here total demand is 34, total supply is also 34. Therefore, the problem is balanced transportation problem. Okay, and now using this Vogel's approximation method, we find penalties for each column and each row. So, let me tell you how to find out these penalties. We start from row wise. So, first let us consider the first row. In the first row, what is the least cost? First least cost is 10 and the next least cost is 19. The difference between these two least costs is 9. 9 is the penalty for first row. And for second row, what is the least cost? First least cost is 30, second least cost is 40. So, the difference is 10. So, this is how we have to find out penalties for each row and each column. After finding the penalty, find out which penalty is highest. So, 22 is the highest penalty. So, for that column we have to allocate. Okay, in that column again to which cell we have to allocate? The cell which is having least cost. Which cell is having least cost? 8. So, 8 is the least cost. To that cell we have to give allocation. Okay, and what is the corresponding supply and corresponding demand? 18, 80 respectively. So, whichever is less, that much assignment we have to give or allocation we have to give. So, 8 is lesser, therefore give 8 units of allocation. That means 8 units must be supplied from S3 to D2 destination. So, 8 units we have already allocated, therefore strike off that column. 18 minus 8 is going to be 10. Okay. So, this is how first we can initiate allocation using VAM technique. Now, in the first iteration, we have deleted second column. For the remaining matrix, again we have to compute row penalty and column penalty for each row, each column again. So, here again the minimum cost is 10, minimum next least cost is 19, okay, and the difference is 9, and likewise we have to do for all the rows and columns. And again look at which penalty is highest. Here it is 21, 10, 10, 9, 20, 20. So, 21 is highest penalty. So, in that column, that is first column, this highest penalty is corresponding to first column. So, in the first column, which cell is having least cost? So, this is least cost. So, the corresponding supply is 7, corresponding demand is 5. 7, 5. Which is lesser? 5 is lesser. Therefore, give allocation 5. Strike off this first column. 7 minus 5 is going to be 2. And now strike off this column also. And again compute. Now we have deleted first column and second column and we are left over with third and fourth columns. Again compute for the remaining values, compute again penalties. So, only 2 values are there in the first row. Find out the difference between these two. 50 minus 10, 40, 60 minus 40, 20, 70 minus 20, 50. Likewise, we have to do for column wise also. Again, the highest penalty is 50, which corresponds to third row. So, we have to, in this stage, we have to give allocation to third row. So, in the third row, which cell is having least cost? 20 is the least cost, that is cell 3, 4, right. So, the corresponding supply is 10, corresponding demand is 14, 10 is lesser, therefore, allocate 10 units, strike off this row. 14 minus 10, 4 units remains. That is 10 units are to be supplied from S3 to D4 destination, from source 3 to destination 4, 10 units must be supplied. Okay. And in the final, so first column, second column, third row were deleted, and for the remaining matrix we have to find out again penalty like how we have done in the previous stages. Again look at which penalty is highest. So 50 is highest penalty. So corresponding to the fourth column, this corresponds to fourth column. Okay, in fourth column, which is least cost? 10 is the least cost, and supply is 2, corresponding demand is 4, which is lesser? 2, 4. 2 is lesser, so allocate 2 units. 4 minus 2 is going to be 2. Therefore, it means that 2 units must be supplied from source 1 to destination 4. And after that, we are left over with only this particular matrix 40, 60. And between these two, which is lesser? It is, okay, we have here it is 40, 60. And difference between 60 minus 40 is 20. So, which is highest? 60 is highest penalty. Therefore, for this cell we have to make allocation, and the corresponding supply is 9 and demand is 2, which is lesser? 2 is lesser. Therefore, allocate to 9 minus 2 is going to be 7. And finally, we are left over with only 40. Demand is 7, supply is 7, allocate 7 units to this particular cell. And now this is the total picture of how we have given allocations using penalties at different stages. Okay, now first let us check out whether there is presence of degeneracy or not. That is, m plus n minus 1 must be equal to number of allocations. M minus 1 plus m plus n minus 1 is 3 plus 4 minus 1, that is 6. So, let us count the number of allocations: 1, 2, 3, 4, 5, 6. So, here there is no presence of degeneracy. The solution is non-degenerate, and the total minimum transportation cost. So, 5 units must be supplied from source 1 to destination 1, and the cost of transportation per unit here is 19 units. Therefore, 19 into 5, and likewise 2 units must be supplied from source 1 to D4, and the cost of transportation per unit is 10 rupees. So, 10 into 2. Likewise, we have to calculate minimum total transportation cost, which is 779. Okay. So, by the end of this lecture, we understood how to find out penalties for each rows and each column, and which cell is to be given after identifying the penalties, which cell is to be given allocation, and how to reach the initial basic feasible solution. Thank you.